Okay, so the example we are looking at says that if sine of angle A equals 6 over 7, then what is the cosine of A and the tangent of A? So when you're given this type of problem, the first thing you're going to want to do is draw a reference triangle to kind of envision what's happening in the situation. So I'm going to do my best to, let's see here, draw this for you. Okay. Not perfect, but that's pretty good. So when you have this type of problem, draw the triangle. We know we're using a right triangle, so there needs to be a right angle in there. And then for angle A, you can choose either of the other two angles. You just can't have the reference angle be the 90-degree angle. So I'm going to put my A in this corner here. Right away, certain things I know about this. The side across from my reference angle would be my opposite side, which you can label as such. The side length across from your 90-degree angle is always your longest side or your hypotenuse. And the last side, which touches your reference angle, meets the reference angle, but it is not the hypotenuse, would be your adjacent side. Okay, so from here, the next thing I'm going to do is write down my mnemonic device to remember my trig functions, which you have learned as SOHCAHTOA. And then I'm going to look back at my problem, and what was given to me is the sine. So if I look at sine up at the top here, sine, sorry, that's a little hard to read. Let me try that again. Sine equals your opposite over your hypotenuse. Okay. And they gave that to us in this instance as 6 over 7. So the 6 in the numerator position tells me that my opposite side has a length of 6. So from my reference angle, we said this was the opposite over here. So I'm going to write in a 6. And I know that the hypotenuse, which is the denominator position, is a length of 7. So I can put that in as well. Okay. So I have a 6. I have a 7. The side length we don't know is our adjacent side. So that is what we're trying to find. When you have two sides of a right triangle, you can use the Pythagorean theorem to find the third side. So I'm going to go ahead and change colors here. When we're looking to find that side length, like I said, we're going to use the Pythagorean theorem, which if you recall is a squared plus b squared equals c squared. Now, when you are using the Pythagorean theorem, the c squared is always the hypotenuse. However, your reference angle, however, your adjacent side length that we're looking for in this case could be represented by the A or the B. So once again, that's the hypotenuse is your C value. But in terms of which, where you plug in the 6, either to A or B, does not really matter. So when I go ahead and do this, I will stick with A squared to represent the unknown adjacent side. And then my B value then would be 6. So 6 squared equals, and then my hypotenuse length of 7, 7 squared. Okay, so we take this a step further. We know A squared plus 6 squared is 36 equals 7 squared, which is 49. We're trying to get A by itself, so we can subtract 36 from both sides. And we find out that A squared equals 13. However, I'm still at an A squared value, and I want A by itself. So I can take the square root of each side. And we find out that A equals the square root of 13. Now, if you were unsure, you could, of course, try a factor tree for 13, but 13 is a prime, so it only breaks down to 1 and 13. So Square root of 13 is really the best we can do for finding the side length for the adjacent side. So we can go ahead and put that in on our original drawing. We now know that this missing side length was square root of 13. Once you have every side labeled, then you can go ahead and find your other trigonometric ratios. So we need cosine and we need to find tangent as well. So let me go back up here. Let's see. I'm going to use green. Okay. So for cosine of angle A, I know looking up at the top here that cosine is adjacent over hypotenuse. So I'm going to write that in, adjacent over hypotenuse. There we go. And now I know these lengths because I've filled in my triangle. So adjacent side to my reference angle is the square root of 13. And in the denominator, my hypotenuse length, which is 7. So that's my cosine of angle A. Tangent, we're going to kind of do the same thing here. So tangent of A equals, again, I'm going to look back to the top at my mnemonic device. Tangent is opposite over adjacent. So I'm going to write that in, opposite over adjacent. Okay. Which would be, let's see, my opposite side length is the 6. And my adjacent is the square root of 13. The only issue with this one is currently I have a square root value in the denominator position. And if you recall, we always want to rationalize the denominator when this occurs. We don't want any irrational denominators. So to do that, we can multiply both top and bottom by that denominator, which in this case is just the square root of 13. So we'll do that. We'll multiply both numerator and denominator by the square root of 13, which gives me 6 square root 13 in the numerator. And in the denominator, square root of 13 times the square root of 13 just gives me plain old 13. So that is how we find the cosine and the tangent. You only need to do that extra step to rationalize the denominator when you end up with the square root value in the denominator position. So if we summarize what we've done here, I'm just going to scroll down and we can write these steps down. Your first step, let me get a new color here. Okay, so your step 1 with this type of problem is you want to draw the triangle. So draw a triangle. Draw a triangle. Pick your reference angle. And label which sides are given. I apologize if it's hard to read the E pen that I'm using, but so we're again, step 1, we're drawing a triangle. You're going to pick your reference angle. Remember that the reference angle cannot be the 90-degree angle, and then you're going to label the sides that are given in the problem. Your step 2 is then to find the missing sides. Find your missing side. Using the Pythagorean theorem. Your step 3 is going to be to label the missing side with the result from step 2. So label your missing side length with results from step 2. So label the missing side with the results from step 2. And your fourth step and final step is to find the other two trig ratios. Okay, so just going back over these 4 steps, we draw the triangle, pick your reference angle and label what's given to you, find your missing side using the Pythagorean theorem, which is what we did here in the pink. Okay. You're going to label the missing side with your result from step 2. We also did that in the same pink color. We were looking for the adjacent side length. And then last but not least, you're going to find the other two trig ratios. That's what we did up here in green. So once you have all 3 side lengths and they're labeled, you can go ahead and use that mnemonic device SOHCAHTOA to help you find your cosine and your tangent in this case, but whichever 2 other trig ratios they're asking you to find. Thanks so much for following along, and I hope that helps.